Well, hello. Welcome to Distance Learning with Mr. Bourbon. Today we're going to work on our forearm mechanics. Your forearm actually acts like a simple machine, a lever, and you're going to learn a little bit about that in class today, and then we'll do a little experiment here. So, first thing you're going to need, an arm. Your own would work, or you can use other people in your house. You'll need some sort of length measuring device. Simple device would be a meter stick or a ruler, but you can even get down to a pencil, anything. We can show you how that works in just a minute. Okay, so what you should do, Flunky, paper please. Pen please. You should first get a piece of paper, and on that piece of paper, you should roughly, you should roughly sketch out your arm. So, here's the outline of an arm. Here's your hand down here. Okay, within your arm, there are bones. Bone, elbow, bone. What we're going to measure today, you're going to lean your arm up against the wall. You're going to measure from the wall to your elbow joint. So we're going to have this measurement. We're going to measure from the elbow joint to this part that's inside your arm, but you will feel it. You have a bicep muscle. There are tricep muscles here. The bicep muscle actually has a tendon that connects right here on your bone. So we're going to measure this distance from your elbow joint to that insertion point of the tendon. And then finally, we're going to measure from that tendon point all the way to right about where your middle finger begins, the end of your palm, right here. So you're actually going to measure three distances. One, from the wall to your elbow. Two, from your elbow to the insertion point of the bicep tendon. And three, from the bicep tendon to about right here, about where your middle finger meets your palm. So we're going to need three measurements today. And here's how we're going to do it. Flunky, hand me a meter stick, please. There you go. Okay, first things first. A meter stick is the best measurement device. If you have one of those available, fantastic. If not, we'll show you other devices that work as well. So meter stick, put your arm flat against the wall, extend your hand straight, and put your bicep into a flex. Yes, Mr. Gruber, that's my flex. Into a flex. Take your meter stick, start at 0, flat against the wall. Now, one of the things you want to find is that point where your elbow joint actually happens in your arm. The elbow joint, hold that please, Flunky. The elbow joint is not at the back of your arm. It's actually a bit in. If you feel around, there should be bony protrusions on both sides. If you move your arm open and closed, you will find where that joint is. Point right on the bumps, that's your point of interest right there. If you come a little too far up the arm, you'll notice it slims up. That's not the right spot. If you go a little bit too far down the forearm, you'll notice you move with it. That's not the right spot. You're right there on the joint. Okay, arm against the wall. I have found my elbow joint. Flunky. Take your meter stick, hold it right here, and you want to approximate as well as you can. Try to get to the 10th, exactly where that elbow joint occurs. So for me, come on in, camera. I am finding that, can you see the ruler? I'm finding mine occurs right around here, which looks to me to be just shy. Maybe I'll put it at about 2.5 centimeters. You might have an inch ruler or some other device, but I'll put it right about 2.5 centimeters. Now you can back up a bit. You want to put your arm in flex because when you are flexing, that tendon actually becomes stiff. Here's the bicep, here's the tendon, and it comes in and connects in your forearm right down here. You'll feel this stiff, stringy thing right here. There's your bicep tendon. That seems to hit for me right around, I'd say about 8.2 2 centimeters. So far I'm at a 2.5 and then an 8.2. We'll do a little subtraction there. Then finally, you can, with a meter stick, you never have to move at all. Run all the way to the point of where your middle finger meets your palm. Mine hits right around 38 centimeters. So those distances, it'll do a little subtraction. But if you come over and look at our diagram, Flunky, may I have a pen, please? Flunky, put your safety goggles on, safety first. If you come over to our diagram, my distances didn't match these spacings, although we're going to need these spacings. My distances were instead from the wall to here, this was 2.5 centimeters. Then from the wall all the way to the insertion point was about 8.2. And then from the wall all the way to the end to about here was about 38 centimeters. Reality is most of you will not have a meter stick at home. Therefore, Flunky, you may have a foot ruler. Ruler, please, Flunky. Thank you. If you have a foot ruler, the process is the same. You have to beware, though. A ruler often has a little gap at the beginning. Mine, I checked, is about 8 millimeters. So it's almost a centimeter gap. It might be a half centimeter gap. Do your best to estimate. Of course, those of you who tape measure at home, this would also work just fine. Pull out that tape. But if you have a ruler like this, put it against the wall. You can do this in inches or centimeters. If I'm going to go back to centimeters, I'd measure at the same distances to the elbow, to the bicep. And then if the ruler is not long enough to reach your middle finger, just take the ruler and slap it right on that bicep tendon and see what it goes up to. Okay? Just remember there's a little spacing there. Now, like I said, you can do this in inches. You can do this in centimeters. You can do this in millimeters. Flunky, may I have the protractor ruler, please?
Oh, protractor.
Thank you, Flunky. If you have this at home, which you're supposed to have, you may want to do this. So this one is nice because there's no gap at the beginning. And for me, I'm getting in inches about, and this will give you a rough idea for your own numbers, I'm getting about elbow joint somewhere on the order of, you will struggle like this a bit yourself, but about 1.25 inches. Then I'm getting the bicep tendon about 3.5 inches. And then this, of course, is not big enough, so 6 inches. And one thing you could do is if your ruler is too short and you're working alone, you could always put a little pen mark on your arm. Pen rubs right off. So, put a little pen mark here at the 6-inch mark. And then, it's good to have a Flunky. Attach it there, and it's almost perfectly another 6 inches, about 12 inches there from here to the finger. So roughly those are your numbers. Here you go, Flunky. One last scenario for those of you who really stuck. No measurement devices at all. Flunky, may I have that pencil and also the Sharpie? Thank you.
But where's the pen?
Here you go, Flunky. Okay, so you could even do this with a pencil if you're really stuck. How does that work? Well, you're going to want a Sharpie. Be careful. I'm going to mark off your spots with any device. So the pencil, mark where your elbow joint is. It's right there on the pencil, so we can put a little mark there on the pencil. That's the elbow joint. Then you could do it again. Mark, and really try to be careful with this. Right there can be the bicep tendon. And then what you can do here is you can actually check on your arm. So, Flunky, may I have that pen, please? Your units of measure can be elbows or biceps. And so the 1 bicep length right here. 2 bicep lengths right here. 3 bicep lengths right here. And finally, almost 4. And you can estimate if it's something like 3 3/4. And you'll see in the lab paper, I'll have it written up, how to do ratios. 'Cause that's ultimately what you're doing. So the unit doesn't matter. Whether you do it in bicep lengths, inches, centimeters, millimeters, whatever it is, we're going to do ratios with the numbers, which means all the units will cancel. And so that won't really matter. Now the whole point of this, Flunky, can you go gather the child? Put your safety goggles on. This part's dangerous. Thank you, Flunky. There you go, Flunky. Doing your job well. Okay, so the point of all this is when you're lifting something by way of your hand or when you're throwing something, are you actually putting the force that you think you are at the gym, for example? So at the gym, maybe you put a dumbbell in your hand that's 20 pounds. And so you do a curl like this. Is your hand pushing up 20 pounds? Well, sure. But is your bicep, that's what's actually pulling your forearm. Is that also pulling 20 pounds of force? Well, you'll see by this lab, we'll talk about it, you'll run through the numbers. You'll be surprised how much force your bicep actually has to apply to this part of your forearm to get it to lift. In fact, you'll start to understand why injuries occur when you load up too much weight here on your hand.
The baby isn't coming.
Uh-oh. Technical difficulty? Flunky might have to be fired.
Oh.
Flunky too.
No.
Where's your safety goggles?
Frankie, safety goggles.
Why does he need safety goggles?
Safety goggles.
All right, Flunky. We found what we need. You need safety goggles first, child.
No.
All right, no safety goggles. Safety first! Okay, here's the point. When you do this, do you want to be a weight at the gym?
Yeah.
All right, you're a weight at the gym. When you do this,
Oh.
Lucy, do you know how much you weigh?
Yeah.
How much?
42.
42? I think you might be around 25, 26 pounds. Is my bicep tendon putting a force of about 25, 26 pounds on my forearm? Well, we'll see about that. Another interesting extension of this, thank you, child. Another interesting extension of this is actually something I speculated on with hand-eye coordination and athleticism. I have an opinion question at the end. The opinion question is, do you have above average hand-eye coordination when it comes to, let's say, ball sports? One of the things I've thought about is, does this ratio here affect you as either a power athlete or as a hand-eye athlete? And we'll see from your results whether any trends come up. Okay, have fun doing a lab.